OceanGate's Titan Submersible. This compact dive craft was conceived with a noble goal to explore the remnants of the Titanic, nestled 3,800 meters beneath the sea. But how did this submersible function? What systems propelled it? And how did these contribute to its catastrophic end? Join me today as we plunge into the ocean depths and unravel the enthralling story of the Titan Submersible. Let's delve into the intricate details of the Titan Submersible. To comprehend the trials confronted by the Titan Submersible, a marvel of engineering, we first need to understand the immense pressure involved. In the oceanic depths, a descent to 4,000 meters below the surface is analogous to a single-legged elephant with an additional 226 elephants stacked atop. The Titan had to bear this colossal pressure along with darkness, frigid temperatures, and communication barriers with the surface. These factors rendered deep-sea exploration a strenuous and dangerous undertaking. The Titan Submersible, weighing approximately 10 tons, mainly comprised several fundamental components. The most notable of these was the carbon fiber hull, which tragically ended up being its failing point. The hull, 5 inches thick, couldn't endure repeated exposure to extreme pressures. On the sub's 7th dive to the Titanic's ruins, the hull collapsed, leading to the death of all aboard. To visualize the disastrous impact, picture a railroad tank collapsing under a vacuum. The external pressure surpasses the internal, causing a rapid implosion. The Titan's hull implosion would likely have been even more instantaneous. You might now be curious about the precautions in place to avert such a catastrophe. The primary defense against failure was the development of a virtual model of the submersible to test its boundaries. Nonetheless, modeling carbon fiber is a daunting task due to its complex structure of interlaced fibers. Without comprehensive destructive testing, the Titan's full limits remained a mystery. This led to the incorporation of a real-time acoustic monitoring system, a secondary defense. Fitted with ultrasonic microphones and strain gauges, this system detected hull vibrations in the carbon fiber and aimed to pinpoint buckling prior to a catastrophic failure. Data from these sensors were gathered regularly and analyzed to gauge the sub's structural health and predict potential failure situations. Regrettably, this testing field was relatively novel and failed to prevent the disastrous outcome. Concerns about the Titan Submersible's design were expressed by the Marine Technology Society in an open letter. Not only was the carbon fiber usage worrisome, but the submersible's cylindrical shape also intensified the pressure distribution problems. A cylindrical shape is far less efficient at dispersing pressure compared to a sphere, escalating the risk of disastrous consequences. Let's now pivot our attention to the Titan's end caps. These components, made of titanium, were fastened onto the primary hull using 19 bolts, creating a hermetic seal. While this design guaranteed structural stability, it also meant that passengers lacked an emergency exit. The observation window, reportedly crafted from a material certified for use at a maximum depth of 1,300 meters, posed another significant concern. The Titanic's remnants, 2,800 meters deep, surpassed the window material's capabilities by a considerable stretch. During the Titan's operation, it was vital to comprehend how the submersible navigated and maintained direction. Post an initial briefing, the first stage of a Titan launch entailed launching the docking station from the primary vessel. This categorization set the Titan as a submersible, not a submarine, as it depended on external aid to resurface. The docking station would fill its ballast tanks with seawater, boosting its weight and causing it to descend 9 meters underwater. The Titan would then disengage from the docking station and start its descent. Simultaneously, the docking station would refill its tanks and ascend back to the surface. Following the journey's completion, the process would reverse to return the Titan to the surface. For deep-sea navigation, the Titan depended on 4 electric thrusters. These thrusters, provided by Innerspace, allowed the submersible to ascend, descend, move forward, backward, and rotate. They were engineered to function efficiently in both forward and backward orientations. The energy for these motors came from an onboard battery system, akin to those in electric cars. Now let's discuss the controls used to direct the Titan submersible. Interestingly, the principal controller used to steer the vessel was a game controller. Although unconventional sounding, game controllers are extensively utilized in several military applications due to their simplicity, robustness, and availability. They currently operate everything from bomb disposal robots to Virginia-class assault submarines. Alongside the game controller, the Titan also featured touchscreen displays, presenting live footage from external cameras and text messages from the surface vessel. However, capturing images in the ocean's dark depths necessitated plentiful lighting. To illuminate its environment, the Titan was equipped with a staggering 40,000 lumens of external lighting, equivalent to about 40 times a car headlight's brightness. Communication and tracking in the sea's depths presented another hurdle. The Titan depended on an ultra-short baseline acoustic system for these purposes. Acoustic pulses, similar to Morse code, were used to transmit messages. This acoustic system guided the Titan sub towards the Titanic's wreckage on prior journeys, as the sub lacked its own navigation system. To ascertain the sub's location, the surface vessel emitted an audio frequency from a transducer. The Titan's transponder received this signal and reciprocated with a similar one, which was then intercepted by the surface vessel. By measuring the signal's receipt time, the surface ship could estimate the sub's distance. Additionally, by using multiple transducers, the ship could identify the audio wave's origin direction. These combined methodologies facilitated accurate positioning and allowed messages to be sent guiding the Titan sub to its target location. As we reminisce about the Titan submersible's tragedy, it is crucial to contemplate the onboard safety systems. In situations where passengers survived, such as power loss or communication disruption, resurfacing was always prioritized. However, in case of fire, additional steps were necessary. To combat potential fires, the Titan was equipped with fire extinguishers and smoke masks for all passengers. However, the most fascinating safety system on board the submersible was a dead man's switch. This switch was designed to function even if all aboard were unconscious. It was made from a material that dissolved upon contact with salt water. After approximately 10 hours of diving, this material would completely dissolve, releasing sandbags from the sub's bottom. Consequently, the submersible would become buoyant and start ascending. Nevertheless, none of these safety systems would have functioned without a continuous supply of breathable air. To maintain a consistent oxygen supply within the hull, the Titan contained onboard tanks. Meanwhile, CO2 was presumably removed via a CO2 scrubber. Sodium and calcium hydroxide, typically used for this purpose, capture CO2 in a chemical reaction, ensuring the air remains breathable. OceanGate's Titanic expeditions carried a hefty price tag of up to $2,500 per person. In retrospect, the Titan submersible's tragic fate serves as a potent reminder of the need to respect the ocean and exercise caution in all undertakings within its depths. Be it energy projects or exploration, the ocean commands our utmost vigilance and meticulous planning. However, one crucial question remains unsolved. What sparked the explosion of the Titan submarine, an engineering marvel? We'd love to receive your thoughts on this in the comments below. If you appreciated this video, please give it a thumbs up. And as always, with that said, thanks for viewing and see you next time.